Good morning, friends. Previously in this chapter we started exercise 12.1 in which we learn about how to write algebraic expression for statement. Before that we learn about the like terms. So let's revise the some concept that we already learned. Like terms. How we can find the like terms? If algebraic factors. Now I hope you clear with what is algebraic factors. Means alphabet are same in two terms, then they become like terms. Now for like terms, what we need to check? We need to check if in a one term we have x and y and in the second term we have x and y. Then both become like terms. We are not concentrate on numerical coefficient. We are not checking the numbers. We are only checking the algebraic factors. For algebraic factors, power of algebraic factors must be same. Means in one term if we have x cube, x raised to 3, and in second term we also have x raised to 3, then only they become like term. Okay, so power must be same, algebraic factors must be same, and we are not concentrating on numerical coefficient. Then we learn about types of algebraic expression, that is monomial, binomial, trinomial, polynomial. What is monomial? If it has only one term. Binomial, it has two terms. Trinomial, it has three terms. And if the algebraic expression has one or more terms, then it becomes polynomial. Okay, so that is what we learn. Now, the like terms concept is useful in addition and subtraction of algebraic expression. So let's solve some example of 12.1 and then we will learn addition and subtraction of algebraic expression. So here identify the terms which contain x and give the coefficient of x. Now we already learned about the coefficient. If it is only about the coefficient, then you need to write the algebraic term and number that is in a multiplication with x, because in question you can say it is write that term with x and whatever that in a multiplication with x, you need to write that as a coefficient. So let's consider first expression. These are the expression given. Now we need to write terms with x and then coefficient of x. So first expression is y square x plus y. So which term contain x? Only this one. So you need to write terms with x is y square x. Now what is there in multiplication with x? With x there is a multiplication of y square. So y square will be the coefficient. Next one, 13y square minus 8yx. So which term contain x? So that is minus 8y square. Do not forget to write sign. So term with x is minus 8yx. Now what is there in multiplication with x? Minus 8y, so that will be its coefficient. X plus y plus 2. Which term contain x? First, so that will be answer. And what is there in the multiplication with x? 1. Coefficient of x is 1. Now next, 5 plus z plus zx. So zx is the term with x. And with x, z is in the multiply, so it will be its coefficient. Next one, 1 plus x plus xy. So here you can see we have two terms with x and xy. So we can write x, xy, two terms. Now coefficient of this x is 1 and coefficient of this x is y, because y is in a multiplication with x. Now next one, 12xy square plus 25. So this is the term with x, so we can write 12xy square. Now what is there in multiplication with x? 12y square. So that will be its coefficient 12y square. 7x plus xy square. So we have two terms with x, that is 7x and xy square. Now for first term, what is there in the multiplication? 7 and xy square. Y square will be its coefficient because y square is in a multiplication with x. Next example is same as this one. Identify the terms which contain y square. Now here we need to write a term with y square and give the coefficient of y square. So let's write here. These are the expression given. Term with y square and its coefficient. This kind of question can be asked for blank or MCQ. So here first 8 minus xy square. Now what is the term with y square? So it is this one. You can write minus 8xy square. So what is coefficient of y square? It is minus x. So that will be your answer. 5y square plus 7x. So term with y square is this one. Now what is that in the multiplication with y square? 5. So it is a coefficient of y square. Now here 2x square y. We need to write term with y square, not y. So you cannot write this because here only one time y. Y square is here and y square is here. So 2 term with y square minus 15x y square and 7 y square. So what is that in the multiplication with y square? Here for first it is 15x and for next it is 7. So these are the terms with y square and coefficient of y square. Now next question, classify into monomial, binomial and trinomial. So expression are given and you need to classify it as a monomial. Monomial means the expression with only one term. Binomial means expression with 2 terms and trinomial means expression with 3 terms. So here first 4y minus 7z. How many terms are there? This is the first term and second term. So 2 terms, so you can write it is binomial. Y square. So that is only one term, so it is monomial. X plus y minus xy. How many terms? 1, 2 and 3. So it is trinomial. Next one 100. So it becomes monomial. Only one term. Now for this how many terms? 1, 2 and 3. So it is trinomial. And 5 minus 3t, 2 terms, so it is binomial. Now next expression is 4p square q minus 4pq square. So that is binomial. It is monomial, only one term. Z square minus 3z plus 8. How many terms we have? Trinomial. It is 3 terms. A square plus b square. For this we have 2 terms, so it is binomial. Z square plus z. We have 2 terms, so it is. Next is 1 plus x square. So here we have 3 terms, so we call it as trinomial. Next example, state whether the given pair of terms are like or unlike. We need to find that terms are like or unlike. Now like terms means if algebraic factors are same, otherwise it becomes unlike. So first 1 and 100. Here no algebraic factor for 1 and 100 does not have algebraic factors, means they are constant sum term, so it is a like term. Minus 7x, 5 by 2x. Here algebraic factors is x, here also algebraic factor is x, so they become like term. Minus 29x, minus 29y. Again we only need to check algebraic factors, so here algebraic factors is x, here algebraic factor is y, so it becomes unlike term. 14xy, 42yx. So 14xy means x and y in multiplication and yx means y and x in multiplication, and we know that multiplication is commutative, means we can change the order. So yx is nothing but xy. So they are like term. 4n square p, 4n p square. In like term, the exponent must be same. Here exponent of n. You already learned about the exponent So here m raised to 2 and here m raised to 1 only. So exponent are different. So these are unlike terms. 12x square z square. Again here exponent of x and z square 2 and here only 1. So these are unlike terms. Identify like terms. So here some terms are given and from that we need to write the pair of like terms. So first here xy square. So which term contain x and y square? Here yx square, not xy square. So this is the term that contain xy square. So first pair is minus xy square and 2xy square. Now second, is there any another term that contain xy square? No, only two terms. Now next one, 4yx square, minus 4yx square. Now minus 4yx square means x raised to 2 and y. So is there any term that contain yx raised to 2? Yes, here x square and y, here x square and y. So these are the like term. You can write it as a 20x square y. Now write the third pair, 8x square. Is there any term with x square? Find the term with x square. So here minus 11x square and you can see here also minus 6x square. So these are the three like terms, minus 11x square, minus 6x square. 7y. Is there any term with y? So yes, it is only y. Let's write the next pair here. Fifth one, minus 100x. Is there any term with x? Yes, minus 100x and 3x. So you can write it is minus 100x and 3x. And next, minus 11yx and 2xy. Yx and xy same. So here sixth pair is minus 11yx and 2xy. So these are the like terms. Next is, again we need to find the like terms. So here 100 pq. First term is 100 pq. So 10 pq. Find another term with pq. So it is here 78 qp. If you write pq or qp, that is same because multiplication is commutative. Next 70. Find the term with p. So it is here 2405p. Now next is 8q. Find the term with q. Here also we have 7 minus 7qp. So we can write here minus 7qp. That is also like term. Now term with q. It is here minus 100q. Minus 20. Minus p square q square. Now find the term with p square q square. So you can see it is here 12q square p square. Fifth one, minus 23. Find the constant term 23 and 41. Minus 5p square. Term with p square. So it is here 701p square. So 13 p square q and this is also p square q. So this to become like that. So we write all pair which are like that. Now next we learn about the adding and subtracting a like terms. So first we only learn how to add like terms. So if we have example like add 6x and 4x. Now you can see both are like terms. So how can we add them? 4x, 6x plus 4x. 4x plus 6x plus 4x. 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 here we can take out x common. 6 plus 4. Here we have x, here we have x, so take out it common. Now 6 plus 4 is what? 10. So that can be written as 10x. Same if we have example like add 4xy, 2xy minus 3xy. So here we can write 4xy plus 2xy plus minus 3xy. All are like terms because all have same algebraic factors. So xy take out common. We can write it as a 4 plus 2 plus minus 3. Now we already learned the addition and subtraction of integers. So 4 plus 2 6. 6 plus minus 3 is 3. That is 3. So answer is 3x. Same if we take example like 6x square y square minus 9x square y square. Add them. So here we can write 6x square y square plus minus 9x square y square. X square y square, that is common. So we can take out x square y square. 6 plus minus 9. 6 plus minus 9 is minus 3. So it is minus 3x square y square. That will be your answer. It means addition of like term of like terms is like term that have numerical coefficient equal to sum of numerical coefficient of like terms. Means addition of two like terms or three like term is a like term. This is xy, this is xy, this is xy, and answer is also xy. Means all are like term. So sum of like term is a like term which has numerical coefficient equal to the sum of numerical coefficient of like terms. Here the numerical coefficient of like term is 4 and 6. So what will be the numerical coefficient of answer? That is sum of numerical coefficient of like terms. Same here, what is the numerical coefficient of your answer? That is sum of like terms. So addition of like terms is a like terms. Why like terms? Because if we add x and x, it is also x. If we add xy, answer is also xy. If we add x square, y square, answer is also x square, y square. So addition of like term is a like term with numerical coefficient is equal to the sum of numerical coefficient of like terms. Clear? Again, addition of like term is a like term with numerical coefficient is equal to the sum of numerical coefficient of like terms. Clear? So that is what about the addition. Now same subtraction if we take example. Subtract 6xy from 10x. So here we can write from 10xy we need to subtract 6xy. So take out xy common. And in bracket we have 10 minus 6, that is 4x. Same if we take one more example. Subtract x square from minus 2x square. So from minus 2x square we need to subtract x square, means we can write minus 2x square minus x square. X square common. Now in the bracket we have coefficient of this one is minus 2. What is the coefficient of this? It is minus 1. So answer is minus 3x square. subtraction of like terms is like term. Why? Because if we take two like terms, then answer is also like term. xy, answer is also xy. If we have x square, answer is also x square. So subtraction of like term is a like term that have numerical coefficient equal to difference of numerical coefficient of like terms. So what is the numerical coefficient of your answer? That is equal to the difference of numerical coefficient of like terms. We cannot perform the addition and subtraction for unlike terms. So you need to remember, we cannot take addition or subtraction for unlike terms. If the terms are like, then only we can perform the addition or subtraction.